Hi everyone, we are back and we are going to do a t-test comparison. So now we've been looking at doing a hypothesis test where we compare the samples to a population and asking, does the sample come from the population with this characteristic or this characteristic? But one of the most important tests that we can run is against one another. So comparing two samples, are they the same? Are they different? Are they statistically the same or different? So that's a very, very important phenomenon to get to. So let's get to it. All right. Anyways, all right. So let's go ahead and we needed to make some changes. So if we're looking at two samples, and we are going to we're going to need to change some of our verbiage up. So we need to create another T experimental. So I'm going to call this T comp. And then I'm going to set this variable. I'm going to create a function. And it's going to be a function again of x1, x2. The order here is very important. S1, S2, so it needs to be consistent. N1, N2. And that's going to be equal to x1 minus x2 divided by, then it needs to be square root of parentheses s1 squared divided by n1 squared divided by n1 plus s2 squared divided by n2. So hopefully that will work. So that's our new T comp. We also need our new comp. So we need to calculate our degrees of freedom. So I'm going to do function. And then this is going to be a function of S1, S2, N1, N2, and it's very ugly. So we're going to do parentheses S1 squared divided by N1 plus S2 squared divided by N2, and then we're going to square that whole thing. And actually I'm going to put another, I know this is ugly looking, but divided by, and then we're going to do this S1 squared divided by N1 squared, and then divided by N1 minus 1. Then we're going to do, plus, and then let's copy that thing, and then just switch it here, and then just change all the n's to 2's, or the 1's to 2's. All right. I know this is boring, but it won't be boring when you use it on an exam, and you'll be thanking me. Anyways, so let's go ahead and we're going to read in some materials now. So I'm going to read in material A. So mat A, I'm going to read, so read underscore SL SX. Mat A dot XLXX. Control enter. I'm going to do also mat B, read underscore XLSX. Meta B dot XLSX. All right. So I'm going to define, so actually we can so let's see if, again, I've got the values in there. How will our confidence interval look? Or how will our hypothesis testing work? We're going to look at, okay, they're the same. So the means are the same. Alternative, means are not the same. So now, let's look at a 95% confidence interval. So our alpha equals 0.05. So 95%. So, but it really means an alpha over 2. So first, let's calculate our T comp. Sorry, my voice is going. So let's do mean of mat A bracket 1. And let's just, before we do that, let's make sure that works. And it does work like a glove. Mat B bracket 1 Actually, let's do, oops. So that's going to be mat B. Then we need the standard deviation. Yikes. Okay. So let's do, it's actually not going to be that bad. We need standard deviation, and then we need the number for our t-comp. So mean, SD, length, and then length. And we're going to control enter that. Oosh, length. So that is our t-comp. So 1.44 something. Okay, let's keep that in the back of our mind. Now instead of t-comp, let's do new comp. So let's look at our degrees of freedom. So here I don't need my means, I just need the standard deviations, the numbers. So basically what I'm looking at here is about 22.3. So I'm going to say that my new, so for this t of 0.025, and I'm going to do 22, that is equal to t of 0.25, 25 and 22, 2.074. Come on, come back. 2.074. My t experimental is like approximately 1 something. So that is a do not reject based on my math. So let's go ahead and check it on the other side. Let's do another type of test. So we can do a very, very cool test as well. We can actually simply look at our t-test, and we can look at, for example, you can put an optional numerical data set. So I can look at mat A, bracket 1, and I can look at mat B, bracket 1, and I can say my conf level equals 0.95. I can say alternative equals two-sided. What else? We can say that the mu's are equal here, or difference in the means. So we're doing a 2-sample test here. So you can see if or difference in the mean. So if we put 0, it means that the means are equal. Excellent. Variance. Let's see, paired. So you can do a paired t-test, or you can do a non-paired t-test too. So let's go ahead and check it out. What do you know? Let's see. Pretty close with our value for t. Actually, perfect. Same thing for degrees of freedom. 0.16 is greater than our 0.025. Do not reject. We got it. There you go. That's what we got. I mean, that's all there. I mean, not all there is to it, but pretty nice. So that is effectively what we've got rolling here. So we will see you all in the next video, and when we do some more examples of t-tests and statistical tests, and next time goodness of fit. So see you in the next video. Thanks. Bye.